the Leetcode questions, and you're watching Expert Honda on the YouTube. So let's go to see the questions. So today questions we have is 1011, and it's a capacity to ship packages within the D days. Okay, so we have given D days, right? Days we have given, and we have to see the capacity to ship the packages, right? So let's read the question. A question saying a conveyor belt has a package, right, and that must be shipped from one port to another within days, right? We have given the days. So ith package on the conveyor belt has a weight of I, and each day we load the ship with the packages on the conveyor belt in the order given by the weight. We may not load more weight than the maximum weight capacity of the ship. Return the least weight capacity of the ship that will result in all the packages of the conveyor belt being shipped within D days, right? So let's understand what we have to do. We have to return the least capacity of the ship that will result in all packages of the conveyor belt being shipped within the D days, right? Within the D days, we have to do. So let's understand example one, in which we have given weights in an array, and we have given days, right? Days we have given 5, and how we have to return, right? So let's suppose this is the we will represent into array. So I'll put into an array. Okay, so first what we have: 1 2 3 4 5 6 7 8 9 and 10. 10 elements we have in the array, right? So we'll start with 0 1 2 3 4 5 6 7 8 9. Okay, these are indexes, right? These are indexes, and these are array element. Okay, and these are array, and this array is what we have weight. Okay, this is weight array, and this is our weight at I. Weight at I is this one, and these are I indexes, right? I indexes is what? 0 1 0 to 9. So I think you understood this one. Now think about given days. Now we have given days is what? 5, right? We have weight, we have given weight array given. So weight of I, if we'll consider weight of I is weight of 0, means we are getting 1, and similarly we'll get all the elements of I, right? All the element at I. Okay, so we have to ship a capacity of 15. Let's suppose is the minimum to ship all the packages in 5 days, like okay. Like if you consider the first day, right? The first day we can take from 0 to 4, you can consider, right? These 4 element. So in day 1, let's suppose 5 days we have. So in day 1 what we have, we can start from 0 to 4, means now we can say 5 we can consider, right? So let's suppose for this one what we have, at 0 we have 1, at 1 we have 2, and similarly till we'll go to the 4 we'll have total 5 elements. If we'll add this one let's suppose we will add, so it is coming 2 and 3 3 6 and 6, and 4 plus 5 is 15, I think, right? Yeah, next 6 plus 9 is 15. Okay, next day 2 we have, if we'll talk about day 2, right? So day 2 will come about what, let's consider. So the first day is, it is coming what, 15, right? So okay, okay, see the capacity is saying the in the expansion is saying the ship capacity of 15 is the minimum to ship all the packages in 5 days, right? So first we got 15, we have capacity 1 to 5 we have capacity. Next day what we have, 6 and 7, so we'll add 6 and 7, it will become 13, right? So it's also fine. On third day we will go with what, so this is done. Now we will have 8 plus 9, right? So third day we will take 8, fourth day we will take 9, so this done. Now we have a last fifth day, that is 10, right? So you can see in here, right? First day we have 1 2 3 4 5, second day we have 6 7, third 8, fourth 9, and fifth is 10, right? So note that the cargo must be shipped in the order given. So using the ship of the capacity 14, ship capacity 14, splitting the package into parts 2 3 2 3 4 5, then we will take 1 6 7, and then 8 9 10 is not allowed. Okay, so we have to ship in the order, right? You can say we have to ship in the order in which it is coming, right? So that's why it is saying the note that the cargo must be shipped in given order, right? The order we have given like this, we have to ship, right? Like this we are shipping, right? We have to do, but we don't, if we are considering shipping of something else, that it will not work. Okay, so the thing is that we have to consider in such a way, right? We will list capacity, we will return the list capacity, like minimum capacity to ship all the elements, you can say. That's why it is saying that return the list capacity of ship that will result in all the packages to convey the belt being shipped within given days, that is days, right? I think you understood, right? Let me erase this one. Okay, so I think you understood. Okay, so first of all, what we have to consider, always we have to consider here is that the weight we have given, and the weight of I we have given, and indexes we have given, right? So main thing we have to consider is the days, right? So if days we have given 5 days we have given, so we have to consider we have to order the ship in such a way, we don't need to forget the order, right? So we have the order like this: 1 2 5, then 6 7, then 7 8 and 9, like this we will do. We will not do like any we will start from the 2 and will consider in the ships next shipment, one will consider next shipment. This will not work, right? So this is the thing it is saying that. And so that let's go to the here and understand another example. Okay, so the example 2 is saying that we have given this one, and DS we have given this one. Okay, so it is saying that the ship capacity is 6, right? And is the this is the 6 is the minimum to ship all the packages in 3 days. Like first we will take 3 2, means capacity is 6 but we are having 5. Now we have 2 4, right? It is coming 6, so it is equal to 6, right? 6 and 1 4, that is 5, it is less than capacity, right? So these are allowed, and so that we are getting output is 6. Similarly we have example 3 in which we have given this one, and days we have given 4. So what we have to do, we have to check the capacities. First day we will send 1, then 2, then 3, then 1 1, like this. Okay, so that our capacity will remain minimum. Okay, now constraint is saying that we have the wait length should be sorry, days should be greater than equal to 1 and should be less than weight of length, right? And weight of I is less than equal to 500. Now this question is very important. Okay, and so that I'll we can say that this is asked in Fank, right? So this question is very important because Google has asked the question, Facebook have asked multiple times, right? And Apple too. So we can say that this question is very important. So please focus on this one to understand this one. Okay, so first of all we'll consider this as a binary search approach, and we are given some package, right, with the weights, given the weights which must be shipped from one port to another. And we have a ship that has some capacity, and it can ship packages in order to given the weight, right? By weight you can say, having a total weight less than or equal to the each capacity each day. Our task is to find the minimum capacity of the ship, so that we can ship all the packages within the given days, right? So our intuition is that we will use the binary search, because this approach would be to start with checking ship capacity equal to the largest weight in the weight, we can say W weight we'll consider, and if the ship capacity cannot be smaller than this weight, right? Ship capacity is not less than this capacity, right? So we'll check if it is possible to ship all the packages within the days using this weight, right? As a capacity of the ship, right? If we are able to ship all the packages within the required days, we have this W as our required answer, we'll say that, right? So otherwise we increment the capacity and try with W plus 1 will do, right? And if we are able to ship the capacity with the required days, right? So we will say W plus 1 is our answer, right? Otherwise what we will do, we will try with the ship capacity as W plus 2. We will increment each time, right? And how long we can go, right? In the worst case, we might need to choose the capacity of the ship equal to the sum of all the weights in the weights array, you can say, and then we will send them all in one day. So our range starts from you can say largest weight and goes until the sum of the weights in the weights, right? So this approach will provide the right answer to all the test cases, right? And but will indicate that the time limit has been exceeded, right? Because in the worst case we might need to check the ship capacity from the large weight to sum of all the elements in the weight. So the sum of all the element can be we can say if because it is giving what, see the constant is given what, weight can be less than equal to 5, right? So in that case, if we'll do the sum of all the elements, this can be reached to n into 500, right? Since 500 is the maximum weight we can have as uh, for the problem constant, right? So we might need to check, right, O of what, n into 500, or you can say O into n into 500, right, like this. So uh, if we might need to check of n into 500 different values of the ship capacity, right? So for each capacity we need to iterate over all the elements of the weight to check whether we can ship the packages in the required capacity of the days or not. This would require what, O of n times, right? So as a result the total time required would be what, we can say O n into n into 500, and that we can say O of n square dot 500, right? And this would lead to TLE, right? So let's think of a faster way by making some observations, right? So if we cannot ship the packages, right, in the required days with the capacity, let's suppose any capacity ABCD, let's suppose capacity is C. So we can never ship the packages with the capacity less than this one, okay, less than C. Also if we can ship the packages in the required days with the capacity, let's suppose C1 and C2, okay, or either we can say A, this was A and this is B, okay. So if what I'm saying that if we cannot ship the packages in the required days with the capacity A, let's suppose with the capacity A, if we cannot ship the packages in the required days with the capacity A, right, so we can never ship the packages with the capacity less than A. Also if we can ship the packages in the required days with the capacity B, right, we can always ship it with capacity greater than B, right? So in such a case, the optimal capacity lies between what? A plus 1 we can say and B. Correct. What I'm saying that if we cannot ship the packages in the required days, right? If we cannot ship the packages in the required days, A, let's suppose A is the capacity. So we can never ship the packages with the capacity less than A, correct? Less than A. We cannot do that here, let's suppose. So uh, we can say also if we can ship the if we can ship the packages in the required days with the capacity B, right? We can always ship it with capacity greater than this, right? Greater than this capacity B. So in such a case, the optimal answer lies between what? I'm saying A plus 1 to B. Both are inclusive. Okay. So here is a scenario this where our task is to search for an answer X from the given range left and right. Correct? Where all the values smaller than X do not satisfy a certain conditions and all the values greater than or equal to X, right, satisfied it, or you can say vice versa. So it can also solve optimally with a binary search algorithm. In binary search, we repeatedly divide the solution space whether the answer could be in half until the range contain just one answer, one element you can say. So let's consider this example that we are talking about, right? So this is a binary search, right? And we have taken what? We have left, we have, let me change the color. Yeah. First we have taken low and another we have right? So search number 7 in the array, right? So what we have to do? We have to check the mid. This is our mid, right? So we'll check 7 is greater than 5, right? So then we will consider what? Right half, this one, and we will not consider this one, right? Next we'll check 7 is greater than 8, right? In this part, in this half that we have taken, right? Yeah. So in this is the mid we have, right? So we'll check 7 is less than, then we will discard this one, we will consider this half, right? So in this half we'll check the mid, right? Which one is mid? Now we'll check 6 7, right? So 6 7 is here, right? This is our, we have selected this one. So mid is what? At here mid is low, right? And high will remain high. So now we'll say 7 is greater than 6, right? 7 is greater than 6, right? Then we'll consider this half, and this is our answer. Okay. So we have seen that low is mid is high, that is what? 6. If both, if all are equal, means 7, then 7 is present at index 6, you can say, like this. Understood? So in this way, right, we have to set the starting of the range to the largest weight in weights, and we'll say max weight, set the ending of the range to the sum of the element of the weights, and we'll say total weight. Okay, so we define two variable, we'll take left and right. Left will be our maximum weight, and right will be our total weight, we can say, right? And then we will indicate the start of the end respectively, and we'll check the end of the range R is always way to shift the shift the weight or not. So let's see the thing, and then we will understand, we will see the approach, right? So I have just submitted this one, so let's understand here. Okay, so first of all, we will initialize two integer variables, right? That is our total load here, total load, and another is max load. Okay. So total load and max load we will take to, we can say, store the sum of all the elements of the weights and max load, that is store the largest element of the weights. Okay. And so we'll create a method, that is we'll check a feasibility method. We'll check feasibility method, and which takes weights and we can say C capacity and days, right? This as a parameter you can say, and it will return true if we can ship all the packages with the capacity, right? So this will check the feasibility just, and it will return you the capacity feasible or not, right? With the capacity C, with the capacity C is it is this package is feasible or not, right? Then what we will do, we will perform our you can say binary search, right? Binary search we will perform, and then binary search we will perform over you can say max load, and this is our max load and total load, you can say over we will perform binary search over max load and total load, and we will create two variables, that is left and right, as you can see that, to represent the beginning and the end of the range, right? This is our beginning range and this is ending range. So we will set left equal to max load, and right is total load, and we can always ship all the weights within the days, d days that we have given with the capacity r, right? So what we will do here, we'll check while left is less than right, means max load is less than total load. Okay, max load is less than total load. Till that we will go and we'll find the midpoint of the range, midpoint of the range, like here mid is left plus right by 2, or you can say uh, left plus right minus left plus 1 by 2, you can also do. So we'll do what left plus right by 2, and this is our mid is a midpoint variables, and then we will call our feasibility, right? Feasibility method that we are talking about, or with the all the mid. What we will do, we'll find our we'll pass our weight, mid and days, to see if we can ship all the weights in the days, right? While using mid as a ship capacity, right? So this mid will be our you can say capacity. For each time we will find the midpoint, and then we'll check the feasibility, right? If this weight is feasible, this shipping capacity is feasible, then we'll consider this as a this midpoint. Otherwise what we will do, we can ship the package with the mid that we have given as a capacity is less than or equal to the days, and then we will move to the lower half of the range by setting uh, uh, right is mid, right is mid. And if we are not feasible, then what we will do, we'll say otherwise if we cannot ship the packages with the given capacity, right, mid capacity, then in the required days, then we will move upper half of the range by setting left equal to mid plus 1, and once this loop is done, right, so you will have our uh, left or right, and when left is equal to right, you can say that is our left, right, and then we will return our left, right. So this capacity, it will return your capacity, you can say. Okay, so no need to go further beyond to understand, right, how it is working, right, how it is working. But as you can see, we are returning the mid, right, and from the mid you will find your feasible feasible thing, feasible baits, and you will return your answer. Okay, so if you like this video, please hit subscribe and uh, subscribe this channel so that you will get more videos like this, right. So if we'll talk about the time complexity, right, we have already seen the capacity we have is we can take n into what log, we can take log also, log of 500 into n, right. This was our uh, you can say time complexity. And if we will re-represent this one, that we have already seen n into log n will have, right, because see O of n is taking time to iterate through the weights to compute the max load to total load, right. And in the binary search, right, we always perform O log n, right. O log n, your O log r is, we can say r is the range of the length, you can say, right. so it will take this time. Okay, so if we'll talk about the space complexity, right, so space complexity will take what, O of 1, because in the space we are not taking any extra spaces, right, and so that space complexity is 1. So time complexities you can represent like this or this, right, and that's all for these videos. Thank you so much. If you like this video, please hit subscribe and comment for this video. Thank you so much.